Hi everyone, today we will see a video on Bipolar Junction Transistor or BJT. So Bipolar Junction Transistor. So bipolar, what is bipolar? In this it indicates that electrons and holes contribute to the flow of current as well as it has two junctions, that is two PN junctions. Okay, we will go into the details of that. Then BJT has three doped regions, that emitter, base and collector. So based on the doping on these regions, that is this emitter, base and collector, it is called whether it is a PNP or an NPN transistor. So, so in a PNP transistor, see the emitter, base and collector. So the emitter and the collector are doped with p-type impurity while the base is dropped with an n-type impurity. Similarly, in the case of NPN transistor, the emitter and the collector, see the emitter and the collector, they are doped with n-type of impurity, n-type impurity, and the base is doped with a p-type impurity. Okay, then generally, what happens in a BJT is like the emitter side, this emitter side will be heavily doped, and the function of this emitter is to supply electrons. That is why it is heavily doped, so it is having a lot of electrons, so its function is to supply electrons. And the base is lightly doped, the base will be usually lightly doped, and the collector will be moderately doped, and base will be a very narrow region. And generally compared to this, I have drawn a little bit large, but this is not the real figure. Generally, no, the base will be very thin or narrow, you can say, and it will be lightly doped, and the collector will be moderately doped, and the collector will be the largest among these three regions, because the collector, as the name suggests, its function is to collect the electrons. So I hope you got the so the heavily doped is the emitter, and the lightly doped is the base, and the collector will be in between this, that is the moderately doped region, and the biggest region is the collector followed by the emitter, and base will be a very thin region. Hope this up to this much it is clear. Now we will see the different regions of operation of a BJT. So it can be easily understood by these figures. Generally, there are three main regions of operation of a BJT. First is called the active region, and second is called the cutoff region, and third is called the saturation region. And there is one more region, it is called the reverse active region, which is generally not used because it's not a very good configuration to use. Okay, we will talk about it later. First we will discuss this main three regions. So first is so this side I have marked it for your understanding, like this is NPN transistor here and this is PNP transistor here. So the active region, it will be like, see the NPN transistor, see the emitter which is heavily doped, and see the size, the size is clear here. The base is having the least base is very thin, and the collector is very large. So okay, so in the active region what happens is, this base emitter, we are applying the voltage between the base emitter, and this will be in the forward biasing, and the base collector region will be in the reverse. So you know what forward bias and reverse bias is. So if you are applying positive terminal to the P side and negative to the N side, then it is called the forward biasing. And similarly, see, positive, this is positive, it is going to the N side, so this will be in the reverse bias. Okay, so the first region, this region, that is base emitter, will be in forward bias, and reverse bias, it will be this base collector region. So in this case, I think it is easy to see, since this is forward bias, no, the positive is connected to the P side, so the voltage VB, this will be greater than VE. That is a simple thing. See, this because it is positive, it is going to the base, so this base voltage will be greater than VE. And here in this base collector region, it is the reverse bias. So the positive terminal is going to the collector, so the collector voltage will be greater than the base voltage. So if we combine these two, and we can say like the voltage at the collector will be greater than the voltage at the base, which is even greater than the voltage at the emitter. Okay, so that is the case. So in the case of a PNP transistor, if you see, so here also, no, this thing will be in the first thing will be in the forward bias, that is the base emitter region will be in forward bias, and the collector base region will be in the reverse bias. So in forward bias, so we have applied a positive voltage to the P side. Uh, Here also you see, so just see the positive is going to the P. So VE should be greater than VB. And here it is reverse bias. So the positive is going to the base, no? So VB should be greater than VC. So that is the general thing about operating the transistors in the active region. And in the active region, the transistors are generally used as amplifiers. So whether it is NPN or PNP, it is used as amplifiers in the active region. See, these are the symbols, generally the symbols of NPN transistor, and this is the symbol of PNP transistor. The only difference is about the current flow. Here the current flows from base to the emitter, and here from the emitter to the base for PNP transistor. So just remember the symbol. And the second region of operation we are going to say is the cutoff region. So in the cutoff region, both will be in reverse biased. That is, the base emitter junction will be in reverse bias, as well as the collector base region will also be in the reverse bias condition. So reverse bias means the positive will be connected to the N side. See, okay. So the positive terminal is connected to the N. So that is the emitter voltage here. VE will be greater than the VB, and here the positive connected to the inside, that is here, that is VC. Collector is their collector, so VC should be greater than VB. So for the case of PNP transistor, you just try for yourself. So and see, the same thing, only both will be in reverse bias. Instead of just draw a PNP transistor and do the reverse biasing, and you can write. So that's it, simple. And there is a third region of operation called the saturation region. So in saturation region, both base emitter as well as the base collector region, these both will be in forward bias. So this will be forward biased and this will be forward biased. See, the positive terminal is connected to the P side. Here also positive terminal to the P side. So this is forward biased, this is also forward biased. So since positive is going to the base, so base voltage VB should be greater than VE, and here also positive is going to the base, so VB should be greater than VC. So saturation region. To operate a transistor as a switch, we switch off between these two regions. So in these two regions, the transistor is being used as a switch. So these are the main regions of operation. That is the active region where active region where the base emitter junction is forward biased and the base collector is reverse biased, and the cutoff region where both are reverse biased, and saturation region where both are forward biased. And in the active region, we use the transistor, whether it is NPN or PNP, as a amplifier, and in the cutoff region and saturation region, we use it as a switch. So hope it is clear.